Okay, so hope everyone is already comfortable. So let's have a discussions on one topic today. So for today, the plan is I would like to discuss and we would like to discuss the last section first, the GOS. Okay, the grade of service, the trunking and the grade of service. So based on the outline, so we are now in the cellular system. So we already look at the cellular concept and frequency reuse. Okay, so if you look back over here, the cellular concept is you need to design a cluster of N. Okay, cluster N, right? So the one of the famous one, N equals to 3, 4, 7, 12, 19. Okay, N equals to 7. So 7 is one of the most popular cluster. Okay. Then once we have cluster, what we do, so the cellular concept is you come with the cluster. Once you are having cluster of 7, for example, this is cluster of 7. Okay, so cluster of 7 meaning that there are 7 cells within one cluster. Then we go to the second concept, which is frequency reuse. So we reuse the same cluster over another so that we duplicate the cluster again and again. Okay, so now we have 2 clusters here. 1 cluster, 2 clusters. So this is the frequency reuse. So we're reusing the same cluster at another area. Frequency reuse. Okay, so we're reusing. So if we put here, this is frequency 1. So frequency 1 will be reused at certain distance. So we have this cell and this cell is what we call as co-channel cell. Co-channel cell because they are cell that is been using the same frequency. So this is the concept that we've been discussing for the past 2 weeks. Okay. And then we look at here, yesterday what we look at system capacity. So we look at how many user per cell. So this is what defining the system capacity. Okay, defining the system capacity. And then we have another one that determine that is the signal quality. Okay, the signal quality. This is given by your C divided by I. Okay, your carrier power divided by the interference. Okay, so there is so this is if P for power carrier for P divided by I because this is capacity. I want to put you C. Okay, channel capacity C, number of user per cell. So we know that there is a trade-off. Okay, for this we have trade-off between C and the CPI. Okay, there is a trade-off. So if we increase the capacity, then your C over I going to reduce. Okay, so one, the capacity is good for the operator. This is good for operator. This is mainly good for user. Okay, one good for user, one good for operator. So this is what we looked at yesterday. Then we stop at channel assignment. So we have 3 types. First is fixed. Second is fixed with borrowing. Third one is dynamic. Okay, so one is dynamic. Okay, so we assign frequency or the channel, the signal channel to the cluster. It's either we assign it as a fixed allocation or fixed And then when we don't, when we run out of the frequency, we can borrow from our neighboring cell, or finally it's a dynamic. We didn't assign it, we put it some sort like in a pool, in a bank. Controller is holding the frequency. If you want it, they will assign it to you dynamically. Okay, so this is where we stop. So we stopped until here yesterday. So this is already been covered. So today I would like to jump straight to trunking. Then before I will go back to hand off, interference and cell splitting. Okay, we will jump straight away to trunking. So today the idea is to cover trunking theory. So if you look at this, the last topic on the second slide is trunking. Okay, trunking. So we know that the idea for the operator is to have as many available channel inside one cell, because this is what going to be used to serve the customer. Okay, so let's go back to a cluster of 7. So we take our example, a very simple example, cluster of 7, 4, 5. Okay, a cluster of 7, and then the available channel, we put it in a simple number. We have spectrum from 1 to 70. Okay, the reason I choose 70 because I can divide it equally into 7 cells. Okay, so let's say we have 70 available channel. So if we use the fixed allocation, so the fixed allocation with an uniform distributed population, meaning that and the area where every place on average we have the same number of people around it. Okay, then it's an easy way to do fixed allocation. We can give 10 to each area. So we have 10 physical channel. In theory, we can only serve 10 at one time. So or at one time we can serve 70. So the ideology is like you have 70 counter in a bank. Okay, we go back to our ideology yesterday. So we have 70 counter. So 70 counter, what does it mean? It means that we can serve 70 customer at one time. Okay, but if we want to serve more than 70, what we have to do is we have to create a waiting area. Okay, so we have 70 people coming in, then someone that is coming after 70, they have to wait for a while. Okay, we give something like a timer, a timer for them to wait. So if there is an empty slot, they can go in. So by having this waiting area, by having the customer to wait, or if they come, it's either this is the first option. Okay, you have waiting area and then going to be served, or you still have 70 counter. But every time if it is more than 70, you just block it. You block the customer. Block customer. What does block customer mean? Customer. Meaning that you ask the customer to come back later. So you refuse to serve, but asking the customer to come later. So once you have these two, you degrade a bit your service, then it turns out that you can serve more than 70 user. Okay, so the number of user that you can serve, the number of customer that you can serve is more than the numbers of counter that you have. In our case, in what we're drawing, 70 counter. Okay, so this is the idea of trunking. So you can see the meaning, that the words there, trunking. What does it mean? A means or a method, a way for providing access to user on demand from available pool of channel. So if we go back to our ideology, a method to provide access or to serve user on demand with the available number of counter. So we go back to our system. The number of counter is the number of available channel. Okay. So is an method to actually serve the customer with the limited or the available number of channel. So the second sentence you said with trunking, a small number of channel. Go back to ideology. What does it mean? When we have a limited small number of counter, can accommodate large number of random user. So this happened because of random user. So we use statistics, probability in here, because we know not 70 people will come at the same time. So there is a statistic there. So the arrival of the user or the customer or the subscriber towards the usage of the channel is random. And because of that, by creating also some degradations in service, asking it's either blocking or ask them to wait, we can actually serve more than the available channel. So, okay, if you go back to our example of serving in the counter, the number of counter. So this is what trunking is. So trunking theory is so with trunking, meaning that within the trunking theory, you can have only a small number of channel, but you can actually accommodate or serve a larger number of user. Okay, the reason why we can do that, because the arrival of the user towards our service is random. We don't have 70 coming, 70. So it is random. So based on that, by having GOS, rather than our first network, our first cluster, which is can serve 70, only have 70 channel, actually it can serve more than 70 user. More than 70 user. If we introduce if we use trunking theory by having certain grade of service. Okay, so any questions on this? The ideology, the counter. Okay, so the theory, trunking theory, is about how a population can be handled by a limited number of servers. So this part, trunking theory, it doesn't mean that it can be applied to a lot of application that is mainly related to it. For example, the one that we just discussed, which is the bank. You can also put it in the internet router. So our internet network will always go to a router. So there will be a lot of data coming in. So you can also use this in order for you to design your buffer. How many buffer you need to design in order for you to serve more, to make sure that more data can pass through one router. It can also be applied in the highway, your toll booth. Okay, so you only have limited number of toll booths. So the idea is, if you arrive, someone is already in the toll booth, you queue. So so trunking theory, then you have another one, queuing theory. So these are all mainly rely on the statistical arrivals of the user in order for them to serve more user. Okay, so in telecommunication, we also have limited number of channel, and because of that, we use trunking theory to increase the number of subscriber that we have, because with the limited number of channels. So this is trunking theory. So initially when we have cluster, we have 10, but now let's look. So today's objective is, let's look how trunking theory, how many user can be served in one cell. So it shouldn't be 10 anymore, it should be more. So and then we'll see how we get that number. Okay, so this is the objective for today's lecture. Okay, any question? So no, then I'll go. So then, based on tracking theory, so then they define grade of service. So in order to introduce some kind of weighting mechanisms or blocking mechanism, then they give this definition, grade of service. So GOS or grade of service is the measurement, or is to measure the ability of a user to access tracking system during the business hour. Okay, so it is given based on likelihood, probability. Okay, it gives based on probability, percentage. likelihood that the call is blocked or delayed longer than certain time. Okay, so GOS is number of lost call divided by number of offered call. So for example, our 1G system, 1980s AMS, the GOS is 2%. What does 2% mean? 2 out of call will be blocked. So on average, every 100 call coming in, they will select 2 randomly that is going to be blocked, that is going to be terminated in randomly. They will choose 2 within every 100 call that arrive, randomly 2 will be straight away blocked, so straight away drop. So meaning that if you are user during that time, the 1980s, when you make a phone call, sometimes it cannot go through at all. There are no ringing tone, or there are ringing tone, and then straight away terminated. Okay, so by having that, you can increase the number of subscriber per cell. Okay, so in here, the objective of our design is to what? Is to get balance, to get a trade-off between what is the cost that you want to offer with how many numbers increment in the number of channel that can be served within one cell. So you don't want to have your cost to be too much. We know that if we go GOS, for example, 50%, we can have more channel. We can serve more user, but it will not make our system desirable from the customer point of view, because definitely you don't want customer to be angry, and at the end customer will not subscribe with you. Definitely they will, you yourself has an handphone, and you know that most of the people will have their um preferred operator. So some people like DG, maybe because the residential area where you live, DG is the strongest operator. Some people may not like DG, they will go for Celcom because in that area Celcom provide a better services. So you also need to play around with cost in order for you to get as many as many subscriber as you want. But at least there is a method on how to boost, how to increase the original physical channel, which is only 10, 10, 10, 10, 10 in each cell. Okay, so now so this is the idea. So at the end, we want to design at reasonable cost, with significant number of increase channel, increase subscriber. Okay, so this is the design objective. You want to have the trade-off between the two, the capacity versus the GOS. So until here, any question, any things that you want to ask? Okay, so there are 2 types of GOS. One is what we call as block call cleared. So this is a GOS system that don't even allow waiting delay. So meaning that if you have GOS 2%, let's say we work at 2%. Right, why can't it? Okay, so let's work at 2%. And okay, so let's work with a 2% GOS. So I have to write here with a 2% GOS. here. 2% loss. What does it mean? It means that two out of 10 calls will be blocked. So there are two types of trunking system. Two types. One, the one that we use Erlang B formula. Second one is Erlang C. Erlang C formula. Okay. So the first one is block. What does it mean? It means that there are no queuing or no waiting, no delay. When you arrive, when within that 100, two of it, once it makes a phone, try to make a phone call, it straight away drop. So this is what we call block call. Okay, and this will give you certain number of increment. The second one is you allow the phone call to be delayed, meaning that there is a ringing tone, kring 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 kring, such a few seconds of delay. If this few seconds of delay is already over, so you actually will need to wait longer, then the call will be dropped. Okay, so the second one is delay. Okay, the second one is delay. So you allow it to wait for a while. So we said queuing is provided to hold call, which are then blocked. Okay, so uh, it will only block. As you can see, GOS is the probability that the call is blocked after waiting at certain length of time in queuing. So this is the second system. This is the first system. First system, no queuing at all, straight away block. Okay, so based on that, it found that, of course, if you are actually asking the user to wait, so you are putting resources more towards it. So it found that definitely Erlang B will have bigger number of subscriber compared to Erlang C. Okay, Erlang C system. Okay, because Erlang C, you still need to give option. You still use your resources to entertain the queuing. So this is one of the things that we have to agree with. Okay, a system that is very harsh to the customer, meaning that we can serve more customer. But if the system put some resources towards it, then the number of service, then the number of service, subscriber that can subscribe or that can entering the system is going to be small. Okay, so this is the main conclusions from these two system. Okay, Erlang B will provide you, will give you more, can can serve more user than Erlang C, because Erlang C we need to put extra effort to allow the user to queue or to wait. Okay, so these are the two. So let's look at Erlang B. So whatever example that we look after this, we look at Erlang B, but mainly Erlang C is the same. Okay, so when we want to look at trunking and grid of service, so these are some of the definition. So we have setup time. What is setup time? The time required to allocate a trunket radio channel to a requesting user. So this is setup time so you can have setup time when you have a delay call. Then you have block call. Block call definitely is a call that is being dropped. So once you request, then there are no available channel, it will be dropped. So it is a lost call. Holding time is how long the user will use the physical channel. So once you make a phone call, how long do you make a phone call? 3 minutes, 5 minutes, 10 minutes, okay, on average. Okay, so this is mainly on average. So certain area has certain different number of holding time. So if you go to the university area, maybe the holding time is longer compared to if you go to office area. Office area, sometimes they want our customer service, they only want to limit the number of, they need to entertain a lot of customer. So it depends on the area. So holding time per area is going to be different. So based on the holding time, this is what given by the trunking theory, traffic intensity. So it is a measurement which is a non, you can see here is a unitless, which is a unitless dimensionless quantity. So there are no unit for this. So when they don't use it, so they only see it as Erlang. So this is where Erlang B, Erlang C coming in. Okay, so it's a measurement of how intensive we are using the traffic is. So later we'll see how this is being computed. Okay, a measure of channel time utilization, which is the average channel occupancy measured in Erlang. Okay, this is a unitless quantity and is denoted by A. So Erlang. So what does it mean? It means that every user will have its own Erlang. Then every trunking system has its own Erlang. So this concept will be clearer when we look at the example. So traffic intensity is Erlang. Then you have load. So load is traffic intensity, the entire trunket system. So what does, so here, this is, for example, we have our 7 cluster. The cluster 7 cluster with the size of 7. So we know that we have 10. Let's say we divide it into equal 10, 10, 10, 10. So 10, 10, 10, 10, 10. And then we know, so with this 70 channel, oops, why? With this 70 channel, you will have certain number of X Erlang. So they will give you what is the traffic that can be carried using the 70 channel. So, okay, I just put the X first. Later we'll see how to get the X. Okay, so within one system, you know how much intensity, the traffic intensity that the system can support. Okay, and then based on that intensity, and we know what is the intensity per user. So we know the trunk traffic intensity, meaning that with how what is the quantity of traffic that can be supported by the system, and we also know the traffic intensity per user. Intensity per user, meaning that one user, how many traffic that is required. So by dividing these two, we will get numbers of user that we can support. So that is the idea. So we have to see how many Erlang this 7 cluster of 7 can support. And then if this is the area where user mainly use about 2 minutes, 3 minutes durations of call, and they will make around 1 call per hour, then you know what is the intensity that the user is using. 3 minutes per hour, which is 3 divided by 60, is around 0.3, 0.05. So that is the Erlang required by the user. Then we know how many user we can support. Okay? Then rate of service later just now, there is 2, Erlang B, Erlang C. Okay. And finally, they have what we call as request rate. Every user, or we will have the request rate. For example, one area, every time a user make a phone call, on average, they will hold to the physical layer. They will make a phone call around 3 minutes. On average, everyone will lose about 3 minutes. Okay? And within one day or within one hour, the same user, or on average, the user will make about 2 calls per hour. So what does it mean? 2 calls per hour, and every call is about 3 minutes, right? 3 minutes. So what does it mean? It means that one user will hold about 6 minutes per hour, right? Per hour. And this will give you 6 divided by 60, 0.1 Erlang. So the traffic intensity for that user, for that area, is per user, they require about 0.1 Erlang. So one user will take 0.1 Erlang. So if the tracking system has 10 Erlang, what does it mean? It means that it can serve 10 divided by 0.1. It can serve about 100 user. Okay, because one user only require about the traffic density of about 0.1. And this trunking system is able to provide until 10 erlang. Then you have more than user you can serve. All of this will be clear once we look at the example. Okay. So these are just the equation from the definition. So traffic intensity is request rate. For example, just now, 2 calls per hour. Okay, everyone, okay, on average, 2 calls. Every call, 3 minutes. Okay, so this is what gives you just now 0.1. Okay, 2 calls per minute per hour. Because minute and hour needs to be cancelled. Okay, so what you get from here is 2 call times 3 minute, 1 per hour. Hour is 60 minutes. So they get 0.1. Okay. So total traffic intensity. So if one cell have 10 user, so meaning that 10 times 0.1, you get the total traffic. Into depending how many user you are serving. If you're serving 20 user, so 20 times 0.1, so you get 20. So that is the total traffic in the system. Okay. Then you can also have traffic intensity per channel. Whatever value that you have A just now, you can divide with the number of available channel that you have within the cell. Okay. So maximum erlang is how many cells you have per area. Okay. So let's look on the so this will be clear later once we look at the example. Okay, so when it comes to Erlang, so this is how you get your traffic intensity. For example, if your blocking is about 2%, if you introduce 2% of blocking and within one cell, just now our cell, we have 10 physical channel per cell. What does 10 mean? Meaning that you have to look here. How many channel you have? 10. Okay, so this is the numbers of channels that you have per cell. So in our system just now we do set equally 10. So per cell is about 10 physical channel. So we have to look at this curve. Okay, we have to look at this curve. So these are the curve for 10 available channel. Now we want to see 2% of GOS. So 2%, 0.1 is what? Is 10%. So 2% is which one? This one, 2%. Okay. So 2% of blockage probability, what you get is you get this point. Okay, you get that point here. And this will give you around that. Okay, so the total Erlang is given by this value X. Okay, so if you have 10 channel, and if you introduce 2% of cost, this is the number of traffic intensity that can be supported in one cell of 10 channel. Okay, so you have to look that part over there. So you need to find what is the traffic intensity in Erlang that can be supported in one cell. Then this one cell is 10 channel. So you can see the bigger the number of channels. So if you look at 100, the intensity is going to be bigger. Of course lah. Okay, it makes sense. Okay, the bigger channel you have, traffic intensity going to increase. So you have bigger channel, you have bigger intensity. So this is the graph that you have to look. You have to find the intensity Erlang. So this is one way. We have graph. The second one, of course, when it comes to graph, you also have table. Okay, Number of channel 10, just now 0.05, 2% tak ada sini. 2%. 2% tak ada sini. So they have 0.02. 0.02. 0.02. Okay, you have about 3.4. So let's hit 0.02. And you have sini here. It's about here. Okay, so that is 3. This is 1. This is 2. This is 3 because this is in log domain 1, 2, 3. So it's actually 3 something. So it gives you 3.43. Okay, let me try to this. Something. So if you have 10, it's not 2. 10, I think 10. There. Okay, so it goes down here. That is the number. So this is 1. This is 2. This is 3. So it's 3 something. Okay, it turns out it gives you 3.43 erlang. Okay, if you take about 0.2%, so if you take 0.2% and you look at a channel of 10 channel per cell, then the number of erlang is about 3.43. Okay, you can have this 3.43 from the graph. So the graph will give you everything, or there will be table. Okay, 10 channel, 0.02, this is the number. This is just a simple table. So you have table like this. Okay, we go back. Number of channel 10, just now is what? Just now is about 0.02. Pun tak ada juga kat sini. Yeah, 0.1. Okay, 0.1. It should be around here, 0.02. It's between these two. Okay, so 0.2 is here. 0.2. Because this is 0.2% straight away. Previously, this is not percentage. This is probability. So there are no percentage. So 0.002 is actually 0.2%. For the table, they already give exactly in the forms of percentage. So what does it mean? 10% over here is 10%, which is 0.1. 0.1. Okay. So let's look at another number that they have. What number over here? You have 0.05. 0.05 ada. Ada. Okay. This one. Let's clear this first. Okay, we do have 0.5 here. So we have 0.5 here. So 0.5%. Okay, so if you look back over here, where's the 10 one again? 10 coming down. There. There. Straight away dekat situ. So 1, 2, 3, around 4. It's about 4. Okay, so if you look back at the table, 5, 10, there, about 4, 3.9, 4. Okay, of course, this is a more accurate number because it's come from the table, so you have that 4. Okay, 0.5 and 10. We give it that. So if you refer to the table, 0.5 and 10, it gives you 4. Okay, 4.0. Okay, so of course from graph you have this slightly different number if you want. So in the exam, the table will be given. So now it's just to find first how many erlang that the system can support. So this case meaning that we go back to our system. Okay, so if one cell we have 10 channel and we introduce 0.5% erlang, what does it mean? It means that 5 out of 1,000 call will be blocked. This is what 0.5% means. 1,000. Okay. 0.5% means that there will be 5 call in every 1,000 call will be blocked. So if you introduce that in your cell, the total traffic, the traffic intensity per cell, traffic intensity will be around 4 erlang. Okay, or 3.961 lah if you have the table. So it will be around 4 erlang. So this is the first thing that you have to do. You need to be able to get what is the traffic intensity with a given number of available channel and your ghost percentage. So you can see if you make the channel even worse, this is 0.5. Let's say you make it here 10%. 10%, what does it mean? 10 or 100 channel, 100 call per 1,000 is going to be blocked. Okay, you reduce the service, the grade of service. The previous one was 5. The second one was 100. And you can see you can support bigger intensity, 7.5. So the traffic intensity that your trunk can support is almost double. It's almost double by just making this from 0.5 to 10%. So you are blocking more channel. You increase the intensity of your cell. So then you have a lot lah, from 1 until 100. Okay, until 100 channel. So this is the summary for from 1 to 100 channel. Okay, 1 to 100 channel. So the same information is here. It's just that when you use the graph, the number that you will see might not be as accurate as in the table. So in here, for example, we look at it at around 4. But if you look from the table, you get 3.961. Okay. So now let's look on the examples. How does this trunking value can increase the number of subscribers? Okay. So we can see here. So for example, how many users can be supported if you have 0.5% blocking probability and the number of channel within one cell is 5, 10, 20, and 100. Let's look at on 5. So you can see if 5, the answer is you can support 11 users. So that is the increment of almost 2 times. So with 5 physical channel, you introduce 0.5% of ghost. So this cell can actually serve 11 users. It's more than the number of physical channel. But if the number of users per cell increase to 100, with the same grade of service, it is 8 times. From that 100 channel can serve 800 users. So the increments of 8 times. So what does it mean? It means that per channel, if this channel is 5, if this cell have 5 channel, and if this cell have 100 channel, the increment, if you put 0.5% for this and 0.5% on this can only serve about 11 users, but this can increase 8 times, about 800 users. So what does it mean? It means that the bigger the number of trunk, the bigger the trunk number, the introductions of trunking theory will have more user. You will have more users. So this is what it means. So it means that you have to start your design with a cell that have sufficiently enough channel. It makes sense. If you go to a counter that only have 3 counter compared to counter that have 10 counter. Okay, so no, one is 5 counter, another one is 10 counter. So the 5 counter can maybe only serve 20 user, but 10 counter it can go up to 100 user. Okay, because of what? Because of 100 user. Because the more counter you have, the more options you have. People coming in, coming out, coming in, coming out. So the probability that the counter is going to be free is also increased exponentially. That is why when you start with a bigger number of counter with the same grade of service, only 5 counter can serve 11 user, but if you have 100 counter, you can serve about 800 users. So the multiplications of users or subscriber that you have with a bigger number of physical layer is more. So this is 8 times, yeah, 100 to what 100 channel to 800 users, 5 channel to only 11 user. So this is about 2 times compared to 8 times with the same grade of service. So this is what it means. So let's look on the first on the how to get the value. Today I will take another half an hour. So I need to complete this so that you will have all the information for you to complete or to start working with your assignment. Okay. So if you have five user 0.5, then you need to go back to the table. So first you have to find the Erlang with 5 channel. With 5 channel, what is the Erlang number? So 5 channel 0.5 Erlang number is, so this system can have 1.132 Erlang. Okay, so this system can get 1.132 Erlang. So we go back to the questions. So that's why you can hear. So with a channel of 0.5, the system can have Erlang 1.13. So this is the total 1.13 Erlang that can be supported traffic intensity. And now it is given one user only require about 0.1 Erlang. If 0.1 Erlang, the cell can support 1.13 Erlang and one user only requires 0.1 Erlang. You divide these two, you get 11 user. So what does it mean? With a 5 channel that can support 1.13 Erlang, it can actually be used to serve 11 user, not 5 user anymore. Okay, so you have an increment of 11 user. Okay. This is how you get the you can increase more the number of subscriber by just introducing 0.5 blocking probability. Now let's look on the question number 2. We go to the extreme. So B and C, please do it yourself. Let's look at 100. So first 100, so we have to go to 100. Okay, table 100 just now was 0.5. 0.5 is 1, 2, 3, 4 is actually column number 4. 1, 2, 3, 4. So the amount is here. Okay. So 1, 2, 3, 4. Sorry. 1, 2, 3, 4, 8, 8, 0, 9, 1. 100. 1, 2, 3, 4 here. Okay, so the Erlang the traffic intensity for 100 channel is traffic intensity is 8091 Erlang. Okay, 8091 Erlang. So we can see for 10, the A is 80.91 Erlang. And AU, one user is using 0.1 Erlang. So number of user is A divided by AU. 80.91 divided by 0.1. That gives you around 809 user. Okay, that is why you get this answer. Okay, so I already do number A and number B. So please do B and C. That is the answer. Okay, so this is because this is assumed, approximated the number of Erlang per user. One user only use about 0.1 Erlang of traffic. Then within any time we can serve at about 800 user by only having 100 channel. So this is how trunking and gauze help to increase the number of user per cell. Okay. So now let's look on the second example. Let's look on the second example. So an urban area has a population of 2 million residents. Okay. So this is environment. Three competing trunk mobile network, system A, B, and C, provide cellular services in this area. System A has 394 cells with 19 channels each. System B has 98 cells with 57 channels each. And system C has 49 cells each with 100 channel. Okay, so if you look, system A, you have a system, whatever system, they didn't mention about the cluster. So one here is 19. And you have how many? So there are about 394 cells. Okay, system A. System B, one cell is about 57 channel and you only have 98 cells. Okay, system C. This is the same area. Eh? So you have 100 channel and only have 49 cells. Okay. So this is to cover the same area of 2 million residents. So you can see system A have less number per cell and then because of that you have a lot of cell. So and then system B, bigger number of user per cell, you have 98 cells in total, C 149. So the question is find the number of user for each system if you introduce 2% of blocking. Okay, if you use 2% of blocking. 2% of blocking. Okay, and you put here average 2 calls per hour at an average call of 3 minutes. So this is to get your EU. What is the Erlang per user? So Erlang per user is they make 2 calls per hour, 2 calls in 1 hour in 60 minutes. And every call is about 3 minutes. Okay, every call is about 3 minutes. 3 minutes on average per call. So that will give you 6. This will give you 6 divided by 60. So per user is 0.1 Erlang. Per user is 0.1 Erlang. So you can also find the same method. So per user 0.1 Erlang, what you have to find is how many Erlang per cell with 19 channel. So this is where, let's say we look at A, system A. Put it here, system A. On the top left, system A. So 19 user, how many Erlang we can get? We go to the table. 19 user, that is 2%. 2% is here. So the Erlang is 12.33. Okay, 12.33. But the example just now is taken from a book that don't have table. So they took it from a graph. So graph 2% is here, 19 is around there. And this is 20. 19. Okay, so it's about there. Okay, so it's about, this is 20 to about 14. Okay, so if you take it from here, it's about 12.33. So if you take it from the graph, normally it's about 12. They will take numbers that is integer. Okay, so the answer here is 12.33 or 12. So let's look on the example. So 19 will give you 12 Erlang. So if it is 12 Erlang, If it is 12 erlang, so how many user you can serve per one cell? So it's actually 12 erlang divided by 0.1. That gives you about 120 user. 120 user per cell. How many cell system E has? 394. Please multiply that with 394. Everyone take 120 times 394. Then you get the answer 47280. So meaning that the entire system that has about 394 cell, one cell can serve 120 user because on average is about 0.1 erlang per user, and with 19 available channel per user, you can have about 12 erlang. So per cell you can serve about 120 user, and this system A has 394 to cover the residential area. So it turns out it gives you 4947280 users. So this is system A. So please do on system B and system C. So meaning that a part of having only 19 channel, you can serve at the end around 47,000 user. Okay, so how many customers? So question number B. Question number B. Okay. So 479 because you get 12E divided by 0.1. Then you get 100 user per cell. Then you get the system A. A is 120 times 394. That gives you 47280. Okay, 47280. Because one cell can serve 120 user, and you have 394 cell, then meaning that you can serve 47,280. So please also do for system B and A. So system B meaning that you have to look at 57 channel. Look at this, and you can find any number over here. And based on that number, will need to divide by 0.1 to get number of user per cell and multiply with the cell. So you should be able to get this answer. It's just that if you get some answer that is slightly different, because for example, the first one we take only 12 erlang. Why is it 12 erlang? Because we didn't take the exact 12.33. We the answer for that taking from the table. So table they will approximate it to be 12. We normally look use integer number. So we can't say 12.5 is fine, but 12.33 we cannot have. So we decided 12 or 13. Okay. So based on the table, normally we approximate it to 12, but based on the graph is 12. Based on table, you can have the exact one. So if you have the exact one, the number is actually bigger. And this number is actually bigger. Okay, so you can increase the number of user per cell now and per network. So that is question B. So what is the market penetration? So for system A, if you only can serve 47,000, so what is the penetration market? Divide by what is the market size? The market size is 2 million. So instead of you serving all 2 million, which is you have 100% penetration, so now you can only serve 47. So that's why you only can serve about 2.36% of the population within the area. So in order to capture more subscriber, you need to modify the system. Okay, so this is the example. So this is the reason why I do it today, because this is mainly the example that will be used to guide your assignment. Okay, your assignment is something like that. So you need to choose an area, the population area, then you need to increase the number of subscriber that you can serve based on the number of limited channel that you have. So you can start your design with 2%, 5%, 10%. Just give the reason behind it, why you choose it. when you do comparison, what are the advantages, what are the disadvantages. Okay, so that is how you use Erlang to increase the number of user per cell. So last question before we go to last question. A, cert, a certain city has an area of N and is covered by a cellular system of 7 cells. They already said 7 cells. So the N equals to 7. These are the things that you have to straight away get it when you read. So each cell has a radius of 4 miles. So the radius, radius 4 miles. 4 miles. Okay, 4 miles. And the city is allocated 40 megahertz spectrum. So you have a 40 megahertz spectrum. 40 megahertz spectrum. And with a full channel bandwidth of 60K. So one channel bandwidth is only 60K, 60 kilohertz. So how many channels you have? Is 40 megahertz divided by 60. So the number of channels is what? Number of channel is 40 megahertz divided by 60 kilohertz. You get 2/3. This is about 666. 667. 2/3. 2000 divided by 3. Okay, so the number of channel is 666. So how many channels how many channel in one cell? How many channels in one cell? If you have 666, this 666 needs to be divided into a cluster of 7. So one will have about 666 divided by 7. That will give you around 95. That is the answer. Okay, number per channel. So you have to compute first number of channel. Then based on that number of channel, you should divide back by cluster 7. Because remember, you have to duplicate cluster after this. Okay. So once you have 95, then the traffic intensity of each cell. So you need to use 95 to get it. So 95, this is 95, then see what are the costs. Okay, in this case is you want to have 0.584. I think this is one. That one over here. Okay, that one over here, 83. The answer is 84. Again, the answer they are using graph. So when it comes to graph 83, 84, you can't make a difference. So around here, 83, 84, you can't make a difference unless if you have table. Have table, then you have the exact figure. Okay, so you have this one. So if you look table, this is going to be 83.13 Erlang. Okay, so when you have that, then what is the maximum traffic? You have to multiply with number of cells. So if one cell is 84 Erlang, 31 cell, you get 2604. Okay, so when you introduce 2%, you can have how many user? Again, you can get from 95, you get the number of user per cell. Then you multiply with 31. So you get the total number of user now that you can serve is 86,000. Okay, 86,000. So the number of mobile per unique area. So how do you get 130? Number of mobile per unit area is you just need to divide the number of user divided by the number of channels, 666. Okay, 86,000. So this is actually 86,000. 86,800 divided by 666. 8,000. So if you can serve in the entire people that you can serve is 86,000. With how many channel? You only have 666 channel. So one channel on average is to serve 130 user. So 130 user can be served by one channel. So in the entire area you get 100 you have only 666 channel and you can serve 86,000. So the last one is the nice one, the theoretical maximum number at one time. So at one time is, at one time you can only have 6, you can only have 95 user. At one time you can only serve 95 user, and how many cells you have? 31 cells. That one gives you 2945. Okay. At any time, if everyone is connected to the service, there are about 2,945 only. This is the physical channel. So 95 channel per cell, and you have 31 cell. So how can you get 31 cell? Final, because that is the one that I missed. How many cell within the area? How do you get this answer? One. So you have an area of 1,300 square miles. Your radius is about 4 miles. So how many cells do you need? What you have to do is 133 divided by the area of one cell. You get 31. You just need to compute what is the area of one cell, which is 4 miles. Okay, so you will get that 31 cells. So the area is 1,300 and one here is only 4 miles. So how many cells that you need to have to cover the entire area? So that area divided by the area of one cell. Then you should be able to get 31 cell. So that area is covered by 31 cell, and one cell is 95 channel, and this 95 channel can serve more than 95 user because you introduce 2% of cost. Okay. So if you can see here, it's about 86,800 divided by 31. So this 95 can serve 2,800 user actually. Okay, so 95 channel can be used to serve 2,800 user by introducing 2% of cost. So there is an answer here. So please try try to get back all the answers. But the idea is by introducing cost, grade of service, certain percentage of grade of service, you can further increase the number of users that you can serve. In this example, the number of channel per cell is 95, but you can use it to serve 2,800 user. Okay, you can get 2,800 user per cell. So that's why 208,000 user multiply with 31 cell, you get 86 user altogether. Within this 31 cell, you can serve 86,800 user. Okay, so the main thing to increase to use 95 channel to serve more user, 2,800 user, is been given by this trunking theory and by introducing grade of service. Okay, so that is Erlang B. Erlang C is also the same. You have your own graph and you have your own table. The only thing is, let's look at one figure. Let's look at 30 and 0.1. So this is Erlang B. You get 16.68. This is blocking 16.68. Let's look on Erlang C. Erlang C 15 point, so 15.80 versus 16 point something. 16.68. This is Erlang C, this is Erlang B. So you can see by putting blockage, you have higher intensity, meaning that the system can have more traffic compared to if you only put delay. So if you delay, you allow the user to wait for a while, then you are putting resources. So that resources goes into entertaining the delay, not into producing the traffic. You can see EB Erlang B having higher intensity compared to Erlang C. When the number of trunking is the same, the number of cores is also the same. Understand? Because if you allowed it to wait, delay, you are putting resources that reduces your traffic intensity. The amount of traffic that the trunk or that the system can actually serve. Okay, so it's just the matter of the number is going to be different, but the idea, meaning that this question I can say here 2%. Instead of Erlang B, I can put Erlang C. So if you want, you can do it Erlang C, you get different number. So the same question is that assume that goes 2% for an Erlang C system. So what does it mean? It means that instead of looking at the Erlang B table, you need to refer to Erlang C table. Everything's are all the same except for the traffic intensity going to be reduced a bit. Okay, going to be reduced a bit. That's all. That's all. Okay. So then you have last one. The last question. An hexagon of 4-cell system with a radius of 1387 kilometer has a total of 60 channels to be used within the entire system. So meaning that you have how many channels you can use? 1 to 60. And this is a 4-cell system. What does it mean? Your N equals to 4. You have system cluster of 4 like this. Then you duplicate. So if this is a cluster of system, how many channel per cell? Say divide by 4. So everything one will get about 15 if you divide it equally. So now you have to work with 15. Use Erlang C 5% probability of delay. Okay, then you have to go 15 and look at 5%. Where is the 15? Let me do this first. 15 percentage, 5%. Erlang C 5%. Percent is here. There. 5% is 9.044. So the intensity here per cell is the Erlang A is 9.044 Erlang. Okay, 9.044 Erlang. If that is the case, so how many user you can serve with 15? So the number of user is A divided by AU. 9.44 divided by one user use 0.29. Okay, 0.29. So that is the number of user that can serve with one in one cell. So it's about 31 user. Okay, with this 15 channel, you can serve 51 user. So within this is 51 user. What you need to find is how many per square feet. Just need to find 31 user divide by what is the area of that. Okay, so you can find the area by having this radius. So you should be able to get 62 user times 2. Okay, so this is actually 2.6 times times 1.387 square. No. Okay. And oh, sorry. 310. Subhanallah. This is not 0.9, 0.029. 9.044 divided by 0.029. Okay, 311. Okay, 311 divided by that. So you should be able to get 62 users. Okay. So you will know within one cell over here, you can serve about 310. So what if you want to know how many user per square feet? So the amount of number of user divided back by the area. So the area you need to know, this is what I asked you to do, the area of the hexagon. 3 square root 3 divided by 2 r square. Okay. Or 2.58 r square. Okay. So with that, you should be able to get the number of users. So please do the example. So the answer is there. But the idea for today's lecture is you can use trunking. So in this case, you have the example that you have for this case. You have a system of tier 4. One have 15 channels with 5% Erlang C, you can serve 311 user. How to get 311 user? This one from the table or graph. Okay, so you need to know how to get that 311 user. Okay, you have to find the Erlang first for the trunking, divide by the Erlang per user, then you should get 311. So with a 15 channel Erlang trunking, the objective of today's class, with 15 channel, you can serve 311 user. Okay, once you have 311 user, the question is asking you per square meter. So we know inside this is 311 user, then you have just need to make sure this 311 divide by the area of the cell. Then you get how many user per square kilometer. Okay, so that is the idea. So idea for today's lecture is this. To get that, either you use Erlang C if delay, or B or block. Okay, so with that, I cover the last one of the topic, how we can, one of the technique, how we can increase the number of user per cell. Because the idea now is we want to serve more, user. Okay, so this is what trunking. A small number of channel can accommodate large number of random user. Example, just now the last one, 15 channel, we can serve 300 user by introducing 5% of delayed system, Erlang C. So with that number, you should be able to increase the number of users. So it goes back to, it goes back to your assignment. So the assignment is also something like that. You choose your own area, you design your own system. Okay, you design your own system. At the end, you should be able to produce answers like how many users you can serve, what is your penetration loss, how much cost is required because how many cells do you have to build. Okay, and how efficient it is, what is the C over I, and so on. Because we have to know C over I needs to go more than 15 dB. Okay, so any questions for today's topic? So if there are no, then see everyone back next week. Thank you so much.
you, Doctor.
Welcome.